All right, guys, here's some support on question number 10 on your spring break activity. All right. So the question says that we need to express in the simplest radical form. All right. So anytime that you see a square root, another name for square root is a radical. So again, another name for square root is a what, guys? A radical. Okay. So I'm going to show you guys two ways that you guys can solve this. Okay. So the first way I'm going to show you guys is by simplifying using perfect squares. All right. So when I say that you're simplifying using perfect squares, we must firstly identify what the first 12 perfect squared numbers are, or numbers that have a square root. So those first 12 numbers are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 9, 4 times 4 is 16, 5 times 5 25, 6 times 6 36, 7 times 7 49, 8 times 8 64, 9 times 9 81, 10 times 10 100, 11 times 11 121, 12 times 12 144. All right. So guys, you need to memorize these numbers. These are all the first 12 perfect squares. Okay. So again, memorize them. So automatically, if I asked you what is 8 times 8 or what is 8 squared, you should say 64. 10 squared, 100. 11 squared, 121. 3 squared, 9. So those should be automatic for you. You should know these numbers like the back of your hand. All right. So what we're going to do is that we're going to use these perfect squares to try to simplify my radical right here. All right. If you realize this is a radical 150 divided by radical 2. Okay. Whenever we are dividing similar radicals, because again, this is a radical and this is a radical, we can actually divide them. Okay. So if I divide radical 150 by radical 2, you'll get radical 75. Okay. So something like that you can just put into your calculator. All right. So what I'm going to do now, guys, is that I'm going to try to simplify this radical 75 using my perfect square. All right. So what I'm going to do is that I'm going to divide this 75 starting with 64. So why am I starting with 64, guys? Because 64 is the largest number that's smaller than 75. Okay. So what I would do, so this one would be very calculator dependent. I will click my calculator and I do 75 divided by 64. And I got a decimal. So that means that one does not work. All right. Then I would try 49. Okay. That one does not work. Then I would try 36. Does not work. Then I would try 25. And 25 works. Okay. So that means that radical 75 can be split up into a 25. And when I divide 75 by 25, I get 3. All right. And what is the square root of 25? The square root of 25 is 5. All right. And then you leave your radical 3 the same. And this would be the answer. All right. So again, guys, that's when you're simplifying using the first 12 perfect squared. All right. So again, that's when you're simplifying using the first 12 perfect squared. All right. But you can actually use another method. All right. So here's the other method. All right. This might actually be a speedier method, and it's actually less calculator dependent. Okay. So this method is called prime factorization. All right. So again, it's called prime factorization. All right. So for prime factorization, all you actually have to remember for this is the first 5 prime numbers. All right. So the first 5 prime numbers are 2, 3, 5, 7, and 11. All right. 1 is not a prime number because for you to be a prime number, you have to be divisible by yourself and 1. All right. 1 is itself, so you can't. So 1 kind of eliminates being divided by itself and also 1 because itself is 1. All right. So 1 is not a prime number. The first 5 are 2, 3, 5, 7, 11. Then the next one would be 13, then 17. But you don't really need to memorize all of those guys. So again, you don't really need to memorize all those. All you need is the first five. Almost all numbers in Algebra 1 can be simplified with the first five, okay? So we need to simplify the square root of 75. So that's what we need to simplify. What I'm going to do is that I'm going to try to divide this 75 starting with 11. Do you think I can divide 75 by 11? No, and if I was supposed to put it in my calculator, guys, I would see that I cannot divide 75 by 11, all right? By 7, no. By 5, yes. So yes, I can divide 75 by 5, all right? So I can divide 75. So again, I can divide 75 by 5. And when I divide 75 by 5, I get a remainder of 15, okay? So now I'm going to try to divide the 15, okay? So again, what I divide by goes on the left. What I get as a remainder goes on the right, okay? 15, can I divide it by 11? No. By 7? No. By 5? Yes. All right. So I can divide it by 5. 15 divided by 5 is 3. Okay. And the only thing I can divide 3 by is 3. But if I divide it by 3, I get 1. All right. And we don't want to really get 1 here. We just want to try to get it to where all of these numbers at the end are prime numbers. Okay. So I have one pair of 5s. So that means I have a 5 on the outside. And then I have a singular 3. That singular 3, I'm going to put a box around it because that's the number that's going to go underneath my radical, underneath my square root. All right? And there we go. Okay? So again, guys, either method works. Okay? I actually prefer to use this method to the right. Okay, because it's a little faster, all right? And because you're breaking them down to the smallest pieces, it's having you trying to divide a lot more and use the calculator less, okay? So again, guys, that's the answer. So let's try another one, guys. So again, for this one, I believe I only required 1, okay? But the more you practice this, guys, the better you'll get at it, all right? 1 question will not be enough. So let's try another one, guys. So let's try another one. All right. So this one, guys, has you multiplying them. All right. So if you realize this is not represented as a fraction, okay. So that means that whenever we see something like this, we can assume they're multiplying because I don't see an addition or subtraction sign between them. Okay. Because this is a radical of 3 and this is a radical of 6. Both of them are radicals. Both of them are like terms, all right? So do you think we can multiply them? Yes, we can, all right? So radical 3 multiplied by radical 6 will give me radical 18, okay? So now I'm going to try to simplify it using both my methods, all right? So you can use this method. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. All right. So again, guys, that's something you need to memorize. All right. So that you guys can get really good at being able to write them out. All right. Very fast. Okay. So I'm going to try to simplify it using our perfect squares. All right. So I'm going to start to divide 18 by 16. Do you think we can divide 18 by 16, guys? No, I cannot. All right. I'll get a decimal. But can I divide 18 by 9? Yes, I can. And why did I start at 16, guys? Because it was the largest number that was smaller than 18. Okay? But yes, I can divide 18 by 9. All right, so I have a square root of 9. And 18 divided by 9 gives me 2. Okay? So I have a square root of 9 and a square root of 2. Okay? And we're going to try to simplify that square root of 9 because we know the square root of 9 is 3. And this would be the answer. Okay? And if we had used prime factorization, I would have listed out the first 5 prime numbers. Okay? And then I would ask myself, can I divide 18 by 11? No. 7? No. 5? Yes, I can. No, I can't. 3, yes, I can. All right. So I can divide So again, I can divide 18 by 3. Oops, it's happening on my board. Okay, so I can divide 18. So, oh, what's going on with my mouse? I'm not sure, guys, what's happening, but all right. So again, we have that 18, 2, 3, 5, 7, 11. Okay. So I can divide it by 3. Okay. And I would get 6. Okay. Now I'll try to see, can I simplify 6 a little bit more? Yes, I can, because I can divide 6 by 3 with a remainder of 2. And all of these are prime numbers. Okay. So now we're going to circle the pair. And then my single thing, I'll put in a box. My pair will go on the outside, and my single thing that's in the box will go underneath my radical. All right? So just like what we got for the question before. Okay? So again, this would be 3 square root of 2. All right. So again, guys, keep on practicing, guys, because the more you do, the better you'll get at this. All right. So for the next one, guys, it says, what is the product of 6 and 9 square root of 75? Okay. So again, guys, product means you multiply. So again, product means you what? You multiply. Okay. So that means I'm multiplying 6 by 9 square root 75. Okay. So first things first, guys, when we're finding this product, we need to multiply the like terms first before we can simplify. Okay. Because this 6 does not have a square root, and this 9, just the 9, is not a square root, it's not underneath a square root, I can multiply the 6 and the 9 together. All right. 6 multiplied by 9 is 54. Okay. And the square root 75 that's beside the 9, I'm going to just bring it down. Okay. The reason we can multiply the 6 and the 9 is because they are like terms. All right. So now I need to simplify that square root of 75 because there is a chance I can simplify it. Okay. So again, guys, I'm going to use prime factorization because that's one of my favorite methods. Okay. And I think it's the easiest method to do it. Okay. So I have 2, 3, 5, 7, 11. All right, so the 75, can I divide it by 11? No. 7? No. 5? Yes. So I can divide it by 5. And then 75 divided by 5 is 15. I can divide 15 again by 5. And then I get 3. All right, and these are all prime numbers. Okay, so that means I'm going to circle my pairs. And then my single person goes underneath my radical. Okay, so I have 54 on the outside. That's this 54 right here. Okay, I have a pair of 5s, so that means I'm going to be multiplying that 54 by my 5. Okay, and then underneath my square root is the 3. Okay, so 5 multiplied by 54 will give me 270. All right, and then the radical 3, the square root of 3, stays the same. All right, so again, guys, just like that. Okay, so I will just put that answer in, 270 square root 3. And as I said before, the 54 that was on the outside, I just brought it down. And in the pairs of 5s, I multiplied that 5 by that 54. All right, so make sure you guys see what I just did right there. Okay, so again, guys, just like that. And again, let's keep on practicing. The more we practice, the better we'll get. Okay, so it says, what is the product of these? Okay, so I have 7 square root 10, and it's, so we need to find a product, and product means you what? You multiply. So again, product means you what? You multiply. All right, so I'm multiplying 7 square root 10, or 7 rad 10 multiplied by 10 rad 15. Okay, so again, guys, the first thing we need to do is multiply the like terms. All right, the 7 and the 10 are like terms because they are numbers that do not have a square root, or they're not underneath a square root. Okay, So we can multiply the 7 and the 10, you get 70. And then the numbers that are underneath the square root are like terms which we can multiply. So that means I can multiply the square root of 10 and the square root of 15, and we will get the square root of 150. Okay? So now I'm going to try to simplify what's underneath the radical. The 70 on the outside, I'm not going to do anything with it as yet. And I'm going to simplify the square root of 150. So the 70 I can bring all the way down, okay? So I'm going to try to simplify the square root of 150 using my first 5 prime numbers, okay? So can I divide 150 by 11? No. 7? No. 5? Yes. Okay. So I can divide it by 5. 150 divided by 5 is 30. Okay. So then I'm going to try to divide 30 again. Can I divide by 11? No. 7? No. 5? Yes. And I have a remainder of 6. Okay. So I can divide 6 by 2 and or 3. Okay. However, I won't be able to simplify it anymore, okay? So again, I can divide by 3 with a remainder of 2, okay? So my pairs, I will circle, so I have a pair of 5s. That means on the outside, being multiplied by my 70 is a 5, okay? And my non-pairs, I put a box around it because those are going to go underneath my square root. They're going to go underneath my radical. And yes, they are being multiplied by each other underneath that radical. Okay? So 70 multiplied by 5 is 350. All right? And 3 multiplied by 2 is 6. All right? So my answer would be 350 square root of 6. All right? So again, guys, I recommend you practice about 10 of these guys because that way you can see all the different variations because all the problems we just did looked all different. All right? So again, guys, let's keep on practicing. The more you practice, the better you'll get. Okay? So again, guys, it says express the simplest radical form. This is a square root. This is a square root. Can we multiply them? Yes, we can. All right. So when I multiply 8 times 20, I get square root of 160. Okay. So let's simplify that square root of 160. All right. I'm going to use prime factorization. All right. So 160, can I divide it by 11? No. 7? No. 5? Yes. Okay. So I can divide it by 5 and then I would get, I believe, 32. Okay. So can I divide 32 by 11? No. 7? No. 5? No. 3? No. 2? Yes. All right. And 32 divided by 2 is 16. Can I divide 16 by 11? No. 5? No. 7? No. 3? No. 2? Yes. And I get 8. And then again, I can divide 8 by 2. I get 4. Divide 4 by 2. And I get 2. All right. And again, all these are prime numbers. Okay. So my pairs, I'm going to circle. So I have one pair of 2s. So that means I have 1, 2 on the outside. But I also have another pair of 2s. So that means I have another 2 on the outside, okay? I have a 5 that does not have a pair. I have a 2 that does not have a pair. So that means those two numbers go underneath my radical and they need to be multiplied by each other, okay? So 2 times 2, 4, all right? And 5 times 2 is 10, okay? So again, guys, just like that, all right? So 4 rad 10. All right. So again, guys, just like that. Okay. So keep on practicing. The more you practice, the better you'll get, guys. I'm telling you. Okay. So like this one would divide them because both of them have square roots. And then I would just get square root 30 divided by 10 would give me square root 3. And that would be the answer. All right. So again, guys, that one was super easy, guys. All right. So that's why I'm telling you to practice as much as you can. All right. Practice as much as you can. All right. Try to do up to 10 of these. If you can do 10, you'll be fine. Okay. So this one, guys, we both of them have square roots. So can I multiply them? Yes, I can. All right. 5 multiplied by 50 would be 250. So square root 250. So let's simplify the square root of 250. All right. And you want to use the other method, guys? Let's try to use the other method, okay? So let's use by dividing by perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. All right, this was actually the method I used when I was in high school, okay? I didn't use prime factorization, all right? So what I'm going to try to do is, can I divide 250 by 144? No, I cannot. So again, guys, I can use the calculator to figure that out, but you can probably assume that you cannot divide 250 by 144. All right. By 121, no. By 100, no, because I get a decimal, okay? By 81, no. By 49, no, by 64, no. By 49, no. By 36, no. By 25, yes, I can, all right? So I can divide it by 25. Okay, I can divide it by 25, and 250 divided by 25 is 10. So I have a square root of 10. All right, and we know that the square root of 25 is what? It's 5, and the square root of 10 stays the same. All right, and that would be my answer. So again, guys, I like using that method instead of prime factorization, because again, that was the method that I grew up knowing. All right, but prime factorization would have also worked. So I can divide it by 5. I get 50. I can divide again by 5. I get 10. And we have a pair of 5s. And then a 10 underneath the square root. All right. So again, guys, this prime factorization is better. It is faster. Okay. But this other method also works. Okay. But it's very calculator dependent. Okay. But I don't want you guys to always depend on calculator. So that's why we've been using prime factorization. All right, which is this method on the right. Okay, so this is prime factorization. Okay, so let's do one more, guys. So let's do one more. Okay, all right, I'm glad that we saw one like these. Okay, because this one looks different. All right, so here we have a square root on the top, and we do not have a square root on the bottom. All right, so we have a radical on the top, but no radical on the bottom. All right, so we need to simplify this. Okay, what I'm going to do first is that I need to simplify the radical first. So again, I need to simplify the radical first before I can do anything else. Okay, so let's prime factorize the 24. Okay, so 2, 3, 5, 7, 11. Can I divide it by 11? 7, 5, no. 3, yes. Okay, 24 divided by 3 is 8, all right? I can divide 8 by 2, remainder 4. I can divide 4 by 2, remainder 2, okay? So I have one pair of 2's, so that means I have 1, 2 on the outside, and then I have one singular 3 and a singular 2, so that means I have a 3 and a 2 underneath my square root, all right? And that's all going to be over 10, okay? So the 2 I'm going to rewrite because 3 times 2 underneath the square root will give me square root of 6 over 10. Okay, and I can simplify the 2 and the 10 because both 2 and 10 are both divisible by 2. It can be simplified. All right, 2 divided by 2 simplifies to be 1. Rewrite your square root of 6. And 10 divided by 2 gives me 5. All right, and this would have been the result. All right. So again, guys, those are all the variations, and I had to do 8 questions for me to be able to see all of the different variations. Okay. So again, guys, that is why I recommend that you do all of these different examples. Okay. So I'm gonna quickly do this one, guys, and this will be my final question. All right. So 36 divided by 8. So this one I might use the calculator a little bit for. All right, so 360 I mean divided by 8 will give me 45. All right, so I need to simplify the square root of 45. Okay, so 45 I can divide by which one? By 5. Okay, and I get 9, and I can divide 9 by 3, and I get 3. So I have a pair of 3's. Okay, so I have a 3 on the outside. and then I have single 5, so I have a single 5 underneath my radical. All right. So again, guys, these both of these questions for this question, if you realize both of them had a radical, that's why I could divide them. All right. The question before, only the numerator was a radical, so I had to simplify it first before I try to divide or simplify anything else. All right. So again, guys, the more you practice, the better you'll get at this.